Chain rule is huge. The chain rule takes everything we've done and it extends it massively. So we're able to do all kinds of problems we couldn't previously do. Like, for example, we could not do, like, we could calculate this. If I tell you that y equals sine x, we can calculate y prime. But if I tell you that y equals sine of x squared plus 1, we don't know what to do, right? Because now we've got a function inside our sine function. We have a composition of functions. And so our rule doesn't allow for that. Our wimpy little rule is only sine x, right? We don't know how to deal with sine of a function of x. Okay, so that's what the chain rule does. The chain rule is really pretty simple. It just says this. It says if you have a composition of functions, if I'm taking the derivative with respect to x of f of g of x, right? So a function within a function, the chain rule just says that you're going to work your way out from the outside to the inside, okay? So the first thing you're going to do is you're going to ignore the inside function, and you're just going to take the derivative of the outside function with respect to g of x. So we're going to get f prime of g of x times, we work our way inside, the derivative of what's inside, okay? That is visually messy, right? And so there's a much easier way to represent the chain rule. Instead of saying the derivative of f of g of x, let's make the simple substitution. Let's just let u equal g of x. And so then the derivative, g prime of x, we'll just call u prime. So you gotta be careful when you say this here. The derivative with respect to x of f of u, it's f of u here, is equal to f prime of u times u prime, okay? Yes?
So at the end, once you like find the derivative, if you multiply them both, so like f prime and u prime.
So let's look at an example. So what does this mean? So we're going to first do the derivative of the function with respect to u. So f prime of u. Then we turn around and multiply by what's inside. Here's what that looks like with a simple function. So what about, oh, that's not what I wanted. Darn it. I'm going to go forward a little bit. Let's do one like this. Okay. So y equals the square root of x squared plus 5. How would we deal with this? Okay, well, we're just going to think about, first of all, what's inside. We're just going to think about that as being u. Let's think about it as hand. Okay. What's the derivative of the square root of x? 1/2 x to the negative 1/2, right? So what's the derivative of the square root of hand? Same pattern. 1/2 hand to the negative 1/2, right? Everybody get that? So the first thing we're going to do is we're just going to take the derivative of the outside function without even bothering looking at what's inside, okay? So the first link in the chain here is going to be this. It's going to be 1/2 times whatever's inside to the negative 1/2, right? Everybody get that? Now what's inside is x squared plus 5, okay? But we don't even have to worry about that. We're just going to follow the rule for hand, whatever is inside the function. Okay, but now we have to peel away the outside layer, and there actually is an internal function here. It's x squared plus 5. And so we need to multiply by the derivative of what's inside. Okay, well, what is the derivative of x squared plus 5? 2x. Okay, and then we're done because there is no function inside that function. And so we had two links in the chain separated by a multiplication sign, right? We just multiply our links because there were two layers to the function. And so when we simplify this, what would we get? Well, the 2 and the 1/2 cancel. We've got a fraction where the x stays on top, and I've got a negative 1/2 power, which is just a square root on the bottom. There's my answer. How easy is that, right? No big deal. Chain rule allows us to take all of our previous derivatives and just apply them to much more interesting examples, okay? So if we go back to our, here's our list of derivatives that we currently know, okay? We know that the derivative with respect to x is just 1, right? How come? Well, here's why. It's 1 because it's really equal to dx over dx. Well, dx over dx cancels, and I just get 1, okay? The derivative of c times x. Well, that's just c times the derivative of x with respect to x, which is c times 1, right? Do we write the dx part? No, it's always the same. We just skip that, right? We just go right to the answer. What's the derivative with respect to x of sine x? Well, that's cosine x times the derivative of x with respect to x. Okay, but dx just goes away, and I just get, by the chain rule, right? And I just get cosine x. Because I've got a sine function, what's inside the sine function? An x. The derivative of sine is cosine. The derivative of x is 1, right? So I don't need to apply the chain rule to the derivative of sine x with respect to x, because this variable and that variable match up, right? What's inside the sine function matches up with the variable of differentiation, what I'm differentiating with respect to. So we don't even bother writing that why we don't need to write that. We don't need to use the chain rule here. Technically we do. You didn't know you were using the chain rule at the time, but we were. It just doesn't buy us anything, right? It doesn't do anything. Same with all this stuff. Same thing here. Technically, the derivative of tangent x with respect to x is secant squared x times the derivative of what's inside tangent, which is just x. Derivative of x is 1. Okay, that's much more interesting when there's something else inside the function. The derivative of u with respect to x is du dx. That's not 1. That's whatever du dx is. It's u prime, depending on what u is, right? Like in our last example, we looked at u was x squared plus 5. So u prime was 2x. Okay, it wasn't 1. The derivative with respect to x of c times u just becomes c times du dx, so it's cu prime. So that's our new formula, our chain ruleified formula. The derivative with respect to x of sine u is sine u times the derivative of what's inside, which is u prime. Okay, we'll look at this in more detail tomorrow. Yep.
This morning in our NHS meeting, everyone voted you to be a speaker. Would you be willing to speak at the ceremony?
What's the ceremony? Is it?
It's the induction ceremony for the new members, like the juniors and the new seniors.
When is it?
Next Wednesday at 6:30.
Next Wednesday at 6:30. Let me see. I think probably I could do that. I mean, like, what's the format and what am I?
Usually I've never been to one because last year we had to do it online.
Mm-hmm.
So we didn't get an induction ceremony, but I guess they usually do seniority and then they wanted to switch it up and everyone voted you, so I don't know. It's supposed to be somebody who's like inspiring. I don't know.
Okay. Yeah, I can do that. I need to. Who do I talk to about? Like the advisor is Mrs. Blanc. Okay, I'll talk to Mrs. Blanc and see what she has to say. Yeah. Okay.
What's Andy's studying? Like, what's his major?
MAE, mechanical aerospace engineering. Yeah. So he'll come out with two engineering degrees: mechanical engineering and aerospace engineering. Yeah.